Okay, some cal1 examples of solving some differential equations. So if we have the derivative dy dx is equal to f prime of x dx, we'll rewrite it in differential form. So dy is equal to f prime of x dx. And the solution to this is y equals, and we have that little s there for the integral sign, f prime of x dx. The f prime of x is called the integrand. So like when you have a radical, the stuff living inside the radical is called the radicand. We have the integrand. Again, this funny looking s, that's called the integral sign, or it means to take the antiderivative. Okay. If we're going to compare the general power rule for taking derivatives of x to the n, so what we do with that is we bring down that n and subtract 1 from the exponent. Okay, so we're going to multiply by that exponent and then subtract 1 from the exponent. Now, if we're going to do it for the antiderivative, we're going to do the exact opposite. We're going to add 1 to the exponent and then divide by the exponent. So if I want to take the antiderivative of x to the n, we're going to add 1 to the exponent and then divide by that exponent. And of course, we have to have that constant of integration because we don't have any initial conditions, so I don't know what the constant value is. So this is just a general solution. And of course, the n cannot be minus 1 because dividing by 0 is no good. We don't want to blow up YouTube. Okay, so we're going to add 1 to the exponent and divide by the exponent. So maybe you need to make some flashcards or something like that, but that's our general power rule. And we're going to practice this a couple of times. So we were going to first just write that general power rule up top for convenience. Okay, so let's solve some differential equations, or diffie-q's. So dy dx is equal to 3. So write it in differential form. dy equals 3 dx. So we just got to think about who do I take a derivative of to get 3. So that's really asking me who has a slope of 3, and it's going to be y equals 3x plus some constant. Okay, so dy is equal to 3 dx. So when we solve that, y is going to equal to the integral of 3 dx, and it's going to be 3x. And before, you didn't see it there, before we have the integrand is 3x to the 0, because x to the 0 is equal to 1. But we're efficient and we don't want to write that down if we don't need it. But it's there. So we're going to add 1 to the 0, so it's going to make it an exponent of 1, and then we divide by our new exponent. Okay, plus our constant of integration. So it's really just 3x plus c. And then we can check by taking the derivative. So 3x plus c, we take that derivative, which is going to be 3. And you see that the integrand matches, and we're good. So we found the antiderivative correctly. Let's do a couple more. So solve dy dx is equal to x. Differential form, dy is equal to x dx. And so we're asking ourselves is, what function has a derivative of x? So you might be thinking like something like an x squared, because when I take the derivative of x squared, I get 2x. So let's go ahead and try that out. So y is equal to the antiderivative of x dx, which is equal to, so we're going to add 1 to the exponent, divide by that exponent, and add our constant of integration. Okay? Add 1 to the exponent, divide by the exponent, add a constant of integration, and then we're going to check by taking the derivative, and that should be equal to the integrand, which is x. Okay? So I take the derivative, take that exponent down, subtract 1 from it, and then the derivative of the constant is 0, so we do have a match. Okay. Alright, what about dy dx is equal to x squared? So dy dx, we forgot something here. We need to sneak in that integral sign. Alright, so differential form. No, we're okay. We are going to do it now. Sorry. dy dx is equal to x squared dx, so differential form. Now we're going to solve it. Then we put that integral sign in. Okay. And you're asking yourself, who has a derivative of x squared? So you might think like a 3x squared, or x to, I'm sorry, not 3x squared, like an x cubed or something like that. So follow general power rule. We'll add 1 to the exponent, which is a 3, divide by that exponent, and add our constant of integration. And then we just need to check by taking the derivative. So we take the derivative. The 3 comes down. Subtract 1 from your exponent, plus your constant of integration. But when we take that derivative, that constant of integration, it's gone. So there's no more constant of integration. And we get x squared. Okay, let's try one more. Do something more exciting. dy dx is equal to 2x to negative 3. So differential form, dy is equal to 2x minus 3 dx. So we solve that, y is equal to, did we forget our equal sign? I better sneak it in there. Okay, there it is. Y is equal to the antiderivative of 2x to the minus 3 dx. And this might be a little bit harder to say or think about who has a derivative of this. So we want to maybe just appeal to our power rule, which is to add 1 to the exponent and then divide by that exponent. Okay, so 2x, add 1 to the exponent, so the negative 3 becomes a negative 2, divide by that exponent, and add your constant of integration. Give us negative x to minus 2 plus our constant of integration. And then we just want to check to make sure it's correct by taking the derivative. Okay, so we use the power rule for derivatives, which says to bring down that exponent. So we have that negative 2 times the pre-existing negative, which cancel each other out, and we're just left with 2. We subtract 1 from the exponent to make it a minus 3, and the integration, what do we want to call? I stumble all over my words here. The constant of integration c, because it's a constant, when I take the derivative of that, it is equal to 0. And we see we have a nice match, and we have happy times of taking antiderivatives.